Now we'll finish the paper in this unit. I'm isolating questions 4 and 5 because I think they are very repetitive questions and you're likely to see them in every exam. Now can I remind you please, I've asked you to make choices in this paper. I did say to you don't do any excess questions because I want you to make rational choices based on what's in front of you. That's very important. I'm going through every part. And when we're finished and when you're reviewing these scripts at a later stage, you'll come to realise that some parts might have been easier than others. Now, you're at a huge advantage now as we go through these last 2 questions because we have stoichiometry done again. And I hope you're looking at these questions again and saying, these aren't too bad at all. Because at the time, many of you would have slipped up on crucial issues here and we must be very careful with that. Question 4 then, the first one is a reacting masses in the sense that it gives me one quantity and a full balanced chemical equation and they ask us to answer various things about it. Question 4, part A. A mass of 6.25 grams of pure copper was reacted with an excess of warm concentrated sulfuric acid to produce copper 2 sulfate, water and sulfur dioxide according to the following equation. Now I've told you already that that's how they present the questions. They give you a full balanced chemical equation, copper plus sulfuric acid, H2SO4, goes to copper sulfate, copper 2 sulfate, H2O and SO2. And please make sure you have it down correctly. There's a 2 in there and there's a 2 there. Will you be very careful you have it down correctly. 1 to 2, 1 to 2 to 1. Very important that you take it down correctly. And they told me that a mass of 6.32 grams of pure copper, 6.32 grams of pure copper was reacted with an excess of warm sulfuric acid, okay, to produce copper 2 sulfate, water and sulfur dioxide. 1, 2, 1, 2, 1. Be very careful with this. Now you know immediately you're given a full balanced chemical equation and you're given one quantity and the one quantity is called the limiting reagent. Yeah, only one quantity. So you make up what I called your mole strip. Are you okay with that? So the ratio strip for a start, here we go again then. This is easy now, we have a lot of control over this. 1, 2, 1, 2, 1. And you put together your table like that every time, okay? And you do that. Now, they're good, and the moles are here then. The moles are here, right? So take that quantity and convert it to moles. Do you know how to convert 6.35 grams of copper into moles? You divide by its AR. Are you okay with that? And when you divide by its AR, which is 63.5, you are going to get, in this instance, you're going to get nearest damn it to 0.1 moles. 0.1 moles. Now I've taken your heads up already. If you're getting a weird number here, will you take it? You're slipping up because that figure would have been selected by the examiner. Give you a nice rounded figure here. So that'll be 0.2, that'll be 0.1, that'll be 0.2, and that'll be 0.1. Now they're all moles, and you answer the questions based on that. How many moles of copper were used? And how many moles of sulfuric acid were used up? Moles of copper were used, there you go. And moles of sulfuric acid used up, there you are. Okay, 0.1 moles of copper, say that. They won't pick it out of that for you, you have to write it down. And 0.2 moles of sulfuric acid. They're the 2 they want for you to start. 0.1 and 0.2 for 7 marks. What mass of water was produced in the reaction? Water is there you go. 0.2 moles of water equals 0.2 multiplied by 18 grams, okay? And that came out to be 3.6 grams. 3.6 grams of water is that, okay? You pick the piece out of the mole strip now to suit your needs. I hope that's okay with you, right? Next, what volume of sulfur dioxide of STP was produced in the reaction? Okay, there's sulfur dioxide, there's the number of moles, 0.1 moles of sulfur dioxide equals 0.1 multiplied by 22.4 liters. Okay, that's the volume you want, and it came out to be 2.24 liters of SO2. Okay, very good. And lastly, how many molecules did this volume contain? Now they're playing with your head there, this volume. It's not this volume, you'll go back to this number of moles. Okay, because if you want to go from there to particles, you have to go back to moles anyway. So, but they said, how many molecules does this volume? This volume is this many moles, so that many moles, okay? So it's 0.1 moles of sulfur dioxide, and you're going to multiply by how many molecules? You multiply by Avogadro's number, equals 0.1 multiplied by 6 by 10 to the power of 23 molecules, okay? And that's your answer. There's nothing further to be said for it. 6 by 10 to the power of 22 molecules. Okay, and label it, please, okay, of sulfur dioxide. Very good. Now, folks, I have to say to you now, why would you not be getting full marks in that? And that the structure is important, that you stay with it, if you have a structure. If you have, you do very well. Now, why would you not be getting full marks in that? And I'd like to think you were growing in confidence here, that you had a sense of what you were doing. Okay, now they gave you one quantity. Okay, sometimes they give you two. We have a third part here now with two quantities, and it'll be interesting how we'll deal with that. Can I get rid of all of that? You're okay. Every time construct a mode strip. Can I remind you again? You cannot construct a mode strip if you don't know the limiting reagent. That's the limiting reagent. It limits how much of that, and that you could produce. Okay, very important. Okay, it doesn't have to be printed there, by the way. It could be here. It could reverse then. That wouldn't matter at all. The 0.1 will be here then, and the 0.2 will be there. They're all multiples of that number. And I've cautioned you about this before now. If you get that number wrong, then it's a very sad story, because all of this will be wrong and you lose a lot of marks. So be very careful, please, that you're aware of what you're doing there. If you do, you won't have any issues. All right, I'll leave that then. Good. That's one part. There'll be 25 marks on that now. Okay, that'll be a nice controlled 25 marks for you. Part B. You're asked to state Boyle's law. You're asked, part 2, a sample of carbon dioxide gas has a volume, a temperature and a pressure, and you're asked to use the combined gas law to calculate the volume occupied by the gas at a temperature and a different temperature and pressure. Now, first of all, we'll just deal with Boyle's law. Boyle's law is a gas that deals with gases at constant temperature. Do you know that? Because that's what you say. Now stop learning these laws. There's an idea behind them. At constant temperature, sorry, I should have said. P, V, T, and N are the 4 variables in a gas. At constant temperature for a fixed mass of gas, the pressure is related to the volume. And what is that relationship? The pressure is inversely proportional to the volume. If you make the volume smaller, you compress the gas so the pressure is bigger. And that's exactly what they want from you, nothing more than that. So at constant temperature for a fixed mass of gas, the pressure is inversely proportional to the volume for 7 marks. Now, I have to say to you, it's not good enough that you wouldn't know that. Okay, there's only 4 gas laws in your course. It's not unreasonable that you would be familiar with them. Now, it gave you a sample of carbon dioxide, it gave you its volume, it gave you its temperature, and it gave you the pressure. And it asked you to use the combined gas law, which I call the general gas equation, right? P1 V1 over T1 equals P2 V2 over T2. In other words, if you're given the volume at one pressure and temperature, you can find the volume at a different pressure and temperature. I would tend to put the ones I'm given here. If I'm given a volume at a pressure and temperature, I could find the volume at a different pressure and temperature. Okay, and that's what you'll be doing there. I think I'm going to leave that one to yourself and just give you the answer. Okay, you put in your values there. Units do not matter with this, as long as they're the same on both sides. Okay, and the units here are pascals and pascals, centimeters cubed and centimeters cubed, and Kelvin and Kelvin they gave you. Okay, so that's fine. So you just put them in and solve for it, and V1 came out to be V1 when you did the calculation. And try this yourself now, please, don't be taking my word for it. 22,408. 408.2 if you want to be fussy, centimeters cubed. Okay, that's what it came out to be. Okay, now try that yourself, run it through a calculator. Do it in stages now, please. I'm always frustrated here. Very good students messing up this stuff. If I was doing that now, I would evaluate that and write down the answer again. I would evaluate that and write down the answer again. I would then divide that by that and write down the answer again. I divide that by that and I'd work from there, okay? So please do it in pieces. Don't be trying to just come up with an answer, okay? It sometimes can be very costly. Now, the next thing it asks you then is taking the values of T equals 273 Kelvin, right? taking the values of 273 Kelvin and the pressure of 1 by 10 to the power of 5 pascals. Take the values, these two values in 2 above as standard temperature and pressure. How many moles of gas are in the sample? Okay, how many moles of gas are in the sample? So they've given you these two and they want to know the number of moles. Are you realizing straight away that this formula PV equals nRT is by far the easiest route to go with? Okay, so you're taking the volume from the last part, V equals 22408.2. Now you've been set up here, I hope you know that. You're being set up. Now I don't want to prompt you for a minute, but do you know where you're going with this? They've asked you, okay, taking the values of temperature 273 and pressure 10 to the power minus 5 pascals in 2 above as standard temperature and pressure. How many moles of gas are in the sample? There's a sample of gas, how many moles are in it? Okay, so you want N. So obviously R equals your usual, okay, you work with that, your value for R and all them are given to you, you have them, okay, and R, and you're looking for A. Are you okay? Now I'm pausing on this because I want you to just decide yourself what you're going to do here. Do you see there's a major error about to be made here if you're not careful? And I'm going to tell you that shortly, I'm not doing it yet. And you're looking for that, are you okay? Do you think you know what I'm going to tell you next? You can't use that formula, okay? They've asked you clearly in this question. I just want to make sure that we're not misinterpreting anything there, okay? Taking that, how many moles? You're looking for N. N equals PV over RT. It is crucial that all those quantities are metric. Now, that's such a common mistake, metric. And they're setting you up there with that, okay? Really be very careful, right? That's equal to, you have to convert that into meters cubed. Are you okay with that? You have to convert to meters cubed. That would be 0.02248082 meters cubed. You divide by 10 to the power minus 6, or move the decimal point 6 places. Are you okay with that? No, sorry, use scientific notation if you want, that's fine. Be careful, please, will you? I think that's all I need to caution you with. Now, you write that out, I hope. You put your 4 numbers in here, evaluate the top line and show me that. I know I'm saying it to you, I don't want to do it now, I want to give you the idea of what you're doing. Evaluate that and show me the result. Substitute in first, right? Substitute in figures first. Evaluate that, show me the result, right? And then evaluate that and show me the result. Okay? Please now, don't be doing it in a single thing. Some of you are running them through calculators, punching figures, coming up with a number, and you're thinking you're great. You're great if it's right, you're a disaster if it's wrong. Now please, it's very important that you don't get this wrong, okay? Must be metric then, that must be converted to that and put it in there. And what did you get? You should have got N equals 0.987 moles. Now that's very important. Okay, now you've been set up there because the two different formula work on different criteria. That must always be metric because that's a metric quantity. So everything has to be metric. That is already metric, that's already metric, that's not. Now please, the error rate there was very high and I'm glad some of you tripped over it because you won't do it again, I think. Okay, but it's a shame because you're so close to the right answer and yet you mess up with that. Please be careful. How many molecules are in the sample? You have moles, so you want molecules. Are you okay? Multiplied by Avogadro's number. Okay? I call that in the end 0.1. Are you okay with that? We just work with that. Just take it in your piece that that's what you're dealing with. You have this 0.98 and you get molecules, okay? Multiplied by 10 to the power 23, you get molecules. Everybody all right with that? And that was that one. Okay, it's not too bad. That's part B then. Just be careful. The two equations are inclined to throw things around for you, so be careful with them, please, wherever you go along. Good? That's all I want. Now, I expect you to go back and try all of these yourself, okay? I expect you to go back and try all of these yourself. The last one of that there, the last answer was 5.922 by 10 to the power of 23 molecules. That's the end result for part B. Molecules, okay? Now please, you need to go back in your own time, your own space. It's very easy to see in exams when someone has put themselves in that position before, where they have actually put themselves in the position of having to deal with the data, list the data. If any of it needs changing, then please change it. That's very important. Okay, you must do that. However you do it, you must do that. And if you do, you'll be fine. But it's important that you work your way through that. That's fine then. And part C now. Part C is demanding enough now. And to be fair to you, it will split on the page. And that always creates a problem with calculations because you're referring back to formula on the previous page. So be careful with it, please. I'm going to read it first for you now. And it's based on an organic reaction. You don't need to know any of these equations. There's no point looking at the equation and saying, well, we never did that. It was never the intention to do that. Your method there, testing, you have everything you want to know in the question. You don't need anything outside that. Distinguish between empirical and molecular formula. Distinguish between empirical and molecular formula. Now, how are you feeling about that? Empirical and molecular formula. Molecular formula is the actual number of atoms of each element present in the compound. Empirical formula is the simplest numerical ratio between the atoms of each element in the compound. Okay? For example, that's hydrogen peroxide. Its molecular formula. That's its empirical formula. Okay? That's water, molecular formula. That's water, the empirical formula. It's the same. Yeah, the common factor is 1, the common factor is 2. Will you keep that in mind? It's the ratio, whereas that's the actual number, and you need to be careful with that. Okay? Now again, I don't want to delve into it here. A previous video has that covered, so you should be able to dip into it again if you need to do so. A sample of ethanol was prepared by reacting ethanol with sodium dichromate and sulfuric acid according to the following equation. Now the equation is everything, as I keep telling you, and I'm going to record that for you for a start. C2H5OH, there's 3 of them there, reacts with the dichromate ion Cr2O7 2-, and acid has to be present, that's the sulfuric acid. And it goes to CH3CHO, which is the product. That's the thing you're trying to prepare. Sorry, no. That's the thing you're trying to prepare. Okay? Ethanol. That's ethanol. Okay? A sample of ethanol was prepared. There you are. The ethanol was prepared, and there's a byproduct of the chromium ion. There's 2 of that there. And there was water as well, H2O, and there's 7 waters there, very good. 7 waters. Now I hope you can read that. I'll go back and again. There's the alcohol, there's the dichromate. You must have acid present to give you the ethanol which they're preparing. That's how you prepare ethanol in the lab. You oxidize the alcohol. Now, you didn't need to know that. You were given the equation. You don't need any more than that. Okay? Now, they've given that full equation, and I'm going to mention to you now as well that they gave you something else. They mentioned sodium dichromate, and they gave you its full formula. Na2Cr2O7 dot, and they gave me what? 2H2O. 2H2O. Now, will you be careful? That's written after the name sodium dichromate. Now, why did they give you that? And the answer is because at some stage along the way, you want to take the mass of that and turn it into moles, so you need its relative molecular mass. You need its relative molecular mass, okay? And that's important. You need the relative molecular mass, and I hope that's okay with you. That is working all right, okay? You can't use that. Look, that's only a bit of that. You see what I mean? That's only the ion from that. You must use that. Whenever they give you the name of a chemical compound, and they give you the full molecular formula after it, you need that to convert to moles, to convert your quantity into moles, okay? Very important that you know that that was given to you for a particular reason. And sulfuric acid is given as well, even though I think you probably won't need much on that. Anyway, they go on to tell you then, and I'm just going to write it here for a moment now, that there is, it says, if 14.9 grams of dichromate, 14.9 grams of dichromate, okay, and 11.5 centimeters cubed of the alcohol, and they give you the density as well. The density is 0.8 in brackets, density 0.8 were used. If 14.9 grams of the dichromate and 11.5 centimeters cubed of alcohol of density that were used, they ask you the following questions. Show which of the 2 substances ethanol or sodium dichromate is in excess. Now, in your defense, I can understand why this was the least popular part of the question. Okay, but that's neither here nor there now. You must realise there isn't much to it. It has to be based on what's on the syllabus and that will show which is, okay. Now, I've given you some tips on this before, and let me just go back for a moment. You can't construct the mole strip now if you don't know the limiting reagent. One of them is the limiting reagent and one is the excess reagent. We need to know which is which. And they've asked you the question there. Show which of the two substances, ethanol or sodium dichromate, is in excess. And so what are you going to do with that, or how are you going to go about it? Well, first of all, let me tip you off now. The minute they give you the density of anything in chemistry, it's probably a liquid. And if it's a liquid, they'll give you a volume. And if they've given you a volume, you need to convert it to grams so you can go to moles. Now, that's very important. Okay, so that's what we do immediately. We must convert that to grams. Okay, and if you've that done, then it's very easy to do that. I'm going to deal with that firstly now. Now, what you have there is 11.5, okay, and it basically has to be converted. So you're going to multiply that by 0.8 and you get 9.2. 11.5 multiplied by 0.8 equals 9.2 grams of C2H5OH. Okay, now you see, you could use that now, sorry, no, excuse me. You could use that to get moles, and that's exactly what you do, right? And that's the way we go about that, okay? You have that many moles, right? So that's equal to 9.2 grams equals 9.2 divided by 46, I think, chancing my arm again. 2 carbons, 2 12s, 24, 6 hydrogens, and 16. 46 is right, okay? And that comes out to be 0.2 moles. 0.2 moles of alcohol. 0.2 moles of that. Now, can I repeat that again because it's very important? Now, repeat that again. They gave you a volume and they gave you density immediately after it. Invariably, anywhere on a chemistry paper they're doing that, they've given you the volume of a liquid. You know, it would sound very silly in everyday conversation. Give me 6 grams of alcohol. We don't talk like that. You'd say, give me 6 centimeters cubed of it. But in order to convert it to moles, you have to go to grams. And density is mass over volume. Density is mass over volume. So mass equals density multiplied by volume. So you simply take your volume, multiply by density, and you have grams. And with 2 grams, it's easy to get moles in. Okay, so we've got moles now of that. That's very good. Now, that's good. There's no problem with that. So we have moles of alcohol. I better just put that right for you for a start now. That's moles of C2H5OH. Very important now. 0.2 moles of alcohol. Now look at the other bit, the other quantity we were given. You were given that many grams of sodium dichromate then. You were given, I'll write this here now, 14.9 grams of sodium dichromate of that. Okay, Na2CO2O7.2H2O. Okay, you must use all of that. Now, a lot of people would use that, that would be a serious mistake. Look, the MR will be much smaller, you get the wrong number of moles. So you must divide that. The MR for that happens to be 298 grams. So obviously that equals 14.9 divided by 298, and that came out to be 0.05 moles of the dichromate. I just write it like that now, Cr2O7 2 minus. Now, I'm breaking one of my own rules there, but look, that's the full molecule. I've just written the active bit of it, okay? That many moles of that, okay? And I've that many moles of that. And the question we're still trying to answer is, show which is in excess. Show which of the two substances, ethanol, are in excess. Now, just hold on a moment. I'm going to write out the ratio strip next. Okay? 3 to 1 to 8 to 3 to 2 to 7. That's the ratio strip for them. Now we can't write out the mole strip for the moment because we don't know what's the limiting reagent. Are you okay? Now I need to make a bit of space there for myself now for a moment, but that's it. I'm going to remove that again. There you are. Okay, so there you're true. There is moles and there's the other moles. Now let's look at this. If you have 0.2 moles of alcohol If you have 0.2 moles of alcohol, right? Or will I put it the other way around? It doesn't make, yeah, if I have 0.05 moles of that, 0.05 moles of the dichromate. How many moles of alcohol will I need for that? And the answer is 0.15 moles. 0.15 moles. But I'm supplied with 0.2 moles. So the alcohol is in excess. Now that's tricky. There's several ways of doing it now, but that's the way I like you to do it. They gave you two quantities and they asked you which, and I'm looking at my which of the two substances is in excess? Which is in excess? Which one do you have more than you need? Okay, and here you go. I converted the two quantities into moles. There's the first quantity in moles, and be very careful now, please, you have to use the full formula, right? Moles, and there's the second quantity in moles, easy enough because that was grams into moles. So, I took one of the quantities, I took that 0.05 moles of that, and asked myself, that would require 0.15 moles of alcohol, but I'm supplied with more of it than 0.15, so the alcohol is in excess. If you found it the other way around, well then you could try the other one, that wouldn't have been an issue. If you put the 0.2 in there, you have to divide by 3, okay, to get the number of moles you need there, and you find that you were short. Okay, so that's the way of doing it. So there is your answer. Can I say it again to you now, please? Every 0.05 moles of dichromate needs 0.15 moles of that. But you're supplied with 0.2 moles. 0.2 is bigger than 0.15. So you're supplied with more alcohol than you need. So that's in excess. And that's exactly what you write in the exam. And wait for it, folks. Very important. Very important. Therefore, that's the limiting reagent. And now we can do any other question they'd ask you on it. That's very important. And so I'm scrubbing that again. Are you okay? And I'm going to just say to you once more, just like I'm going to read those two numbers there for a moment. That one and that one. You basically convert your two quantities to moles and use the ratio between them to find out if you had that much of that, how much of that would you need? 3 times it. Is that more or less than what you're supplied with? The answer is that's less than what you're supplied with. Therefore, that substance is in excess. I have more of that than I need. Therefore, that's in excess, so that has to be the limiting reagent. Now, they didn't ask you this here. They asked you to calculate the percentage yield. I'll deal with that in a moment. But they could now have asked you, you know, what mass of ethanol is produced in this reaction, or how many molecules of water, in which case you have to set up the mole strip. Now I'm stressing, this is not part of the question, because the questions coming up in 10 and 11 in chemistry are 3 half questions, of which you do 2. Will you take it, please? They're often set as full questions and they reduce them so that they will fit the mark allocation and consequently leave bits out. But if this was a fuller question now, here's what you'll be doing immediately. Here's what you'll be doing. Now that we've established that's in excess, that's the limiting reagent, look, that must go for the mole strip. You never use that quantity in the mole strip, okay? You use this quantity, okay? Use this quantity and you get that right then, okay? And you're away with that then. That's exactly what you want, because when you're working with that, that's the way you go about that, okay? That you had it there already, and effectively 0.05 here, 0.05. So that'd be 0.15 for the moles. And this will be multiplied by 8, 0.40, 0.15, 0.10, and 0.35. Okay, and you could answer anything then based on that, if you know what I mean. Now, you weren't asked that, but I'm just making a point here. This mole strip is dependent on the limiting reagent. They didn't ask you that here. That's the point I'm making sure. That's very, very important that you work with that. Now, let me stay with that a moment and I'll give you a break again, then we'll just do this here. The last part of it now asks you to calculate the percentage yield given that 1.6 grams of ethanol. Now, we're getting rid of that again. You don't need it, right? Getting rid of that again now. Getting rid of that. Yeah, 1 point, okay, I think I can do that. I'll put it back in for you, I think, because it would be useful. Just, you'd set this up then, right? You have your 0.5 here that I had already. I want to make sure that we only put in the data we want here. 0.05. Here is the yield, that'll be 0.15, okay? And they're the only 2 bits you need for the moment. Now, percentage yield equals actual yield over theoretical yield multiplied by 100. Okay, actual yield over theoretical yield by 100. Are you okay with that? In the question itself, it gives you the actual yield. It gives you the actual yield. It says calculate the percentage yield. They've already told you they were preparing ethanol. So you're yielding ethanol. That's implied in the question. Given that 1.6 grams of ethanol were produced. So you have 1.6 grams of CH3CHO were produced. That's the actual yield. That's going in there. Okay, the theoretical yield is got from here. Okay, the theoretical, that's the biggest possible amount of ethanol you could get. Because when the limiting reagent runs out, you get no more. Okay, and that's very important. Now, all the other bits could be in there as well. I didn't bother with them now, they were there already, but they could be there, okay? In other words, I would have set up the most script for the percentage yield. I would have done that anyway, but they're the only bits I need at the moment, so I'm taking that now. That's the theoretical yield, okay? That's the actual yield, and the theoretical yield is here. 0.15 moles of CH3CHO equals 0.15 multiplied by, I brought it to grams for you, and it came out as 6.6. Yeah, it did, yeah. Multiplied by the MR for that. 2 carbons, 2 12s, 24. 4 hydrogens, 24. 4 hydrogens, 4 ones, and 1 oxygen, 16. That's 14, that's 44. Multiplied by 44, and I got there for that, the theoretical yield came out to be 6.6 grams. So there you have 1.6 grams over 6.6 by 100 is the percentage yield. And that equals, and you came out with a value there, the percentage yield came out as 24.24. Okay, it came out as that. Now I'm saying for the last time, they gave you the actual yield in the question. If you were doing the experiment, you'd end up with the little flask at the end with your product in it, and you could have weighed it. But in an exam, they'll give it to you. So they gave you the actual yield, right? They gave you the actual yield. They used the moles strip to get the theoretical yield. That's the theoretical yield, okay? Convert that to grams. Grams over grams by 100. By the way, you could have taken that many grams and gone to moles and divided moles over moles by 100. That'd be fine. Moles over moles by 100, grams over grams by 100 is fine. And there it came out as 24. So only a quarter of this stuff was converted to ethanol. And they might ask you, they won't ask you directly in the calculation, but why would that be? Where did you lose the 75%? Well, if I told you ethanol has a very low boiling point, you probably understand that a lot of it would evaporate when you're preparing it. And that wouldn't be unusual to do that, you know, and that's very important. Now, let me break this unit again here because there's a lot to be revised in that. Now, please, the whole idea is that you go back on the question and that you try it yourself again, and maybe then you need to look at the video again, right? Because it's important that you get your head around that. I was unhappy that that question was broken up into two, half on one page and half on the other was not good. All right?